Welcome to week 5. At the end of this week, we'll be 30% of the way through the semester. I have a couple of announcements. The first test is in 2 weeks, so I want to show you a few things about that. On Friday, what's going to pop up for you is at the end of Module 9, the Unit 1 test. And the Unit 1 test covers lessons 1 through 9. There's 2 practice tests for you that are essentially like homework. You'll have 3 tries for each of these, and I broke it up to part 1, part 2, because the part 2 is more of the second half of the class, but not exclusively. Part 2 is more writing involved, basic written up solutions for you for that second part. The test, you will have all day to work on the test, and it is due at 11:59 on Tuesday, October 6th. I give you all day because I want to make sure that you have the time and the space to block out a 2-hour period, because you only have 2 hours to do the test, although it is written to take you a little more than an hour. I think most of you will probably finish in about an hour, 15 minutes, hour and a half. Okay, but I want to give you a little extra time because you're going to be sifting through your notes and such. In order to make this as efficient as possible, I suggest you with every lesson write a little summary, like a Cliff Notes version of what was in that lesson, so you're not spending a whole bunch of time flipping. But I want to make sure we all understand the rules. I'm not proctoring the test. I'm not requiring any software. I am trusting you on your honor that you will follow the rules and only use acceptable devices and resources. Let's talk about what is acceptable and what is not. You may use any notes that you've created for this class and your graphing calculator. You may not collaborate with other students, tutors, other people, or the internet, and you may not use any notes beyond those that you created for this class. Please don't be a cheater. All I ask is that you just do your best. Right? This isn't a huge portion of the grade, so don't sweat it too much. You see there's a little timer over here because you have 2 hours. The timer starts counting down as soon as you open the test. You can hide the timer. I've also put my cell number right here on the test, so if you encounter any problems, just text me, and it's helpful if you also send me a screenshot. There's 26 questions, but many of these questions have more than one part. Just like you've noticed in the homework, here's some information, and then there's a bunch of questions about that information. If this time is a quiet time for you, I would suggest you just do the test during class time. Maybe start a little bit early if you have an obligation after class. There will not be any class on Tuesday, October 6th. That time is just for you to be working on the test. I will be available for questions all day long. You have a week and a half to work on those reviews. So find time in your schedule to add those reviews to all the regular coursework. This is a college class, so the coursework does not stop just because we have a test coming. If this deadline has gotten ahead of you and you're kind of surprised by it, I want to remind you that you can find the class calendar, Canvas course, under Start Here Course Orientation. And down here is the class calendar. It occurred to me, I forgot to mention something last week. Remember in lesson 4, we were talking about the clinical trials, and there was a question about inclusion and exclusion criteria. I found the actual protocol for the COVID study we did. That's on that lesson 4 in-class discussion. If you scroll down here, I put the full study design. An example of exclusion criteria would be if you are pregnant or breastfeeding, because that change in hormones has an effect on your response to medication. One more thing is, if you still don't have a calculator, please do one of those 2 things. Please either, and you need to be able to get familiar with the calculator before the test. You don't want that first time you have the calculator to be the test when you're struggling trying to figure out how to use it. I would strongly urge you to download one of these things. Before we go into lesson 7, I just want to point out something about lesson 6. On lesson 6, we were doing histograms. With histogram, we took the data and we divided it into boxes of equal width. We used the mean and the standard deviations to find if things were unusual based on data put in boxes of equal width. Now for lesson 7, we're going away from histograms and we're going to box plot. Box plots, instead of dividing the data into bins of equal sizes, we're dividing the data into 4 groups of equal size. All right, and that allows us to see the spread easier. It allows us to see outliers easier. It allows us to see where most of the data lies. And if you remember with the histograms, most of the data lies between 1 standard deviation away from the mean. Box plots, it's the same idea essentially, but looking at the data in a slightly different way. They kind of have different purposes depending on what the data looks like and depending on what it is we're trying to find out about. Let's talk about how to divide the data into 4 equal parts, an easy way to do that. All right, and I like to think of dividing the data like how you cut a pizza. What's the first thing you do when you cut pizza? What's the first cut you make? Do you cut out one little slice? You cut it in half. That's what we want to do with the data when we're figuring out the box plots. We want 4 equal groups. The first and easiest thing is to cut it in half and then cut each of these halves in half separately, and then you wind up with 4. We know we have 54 pieces of data. So to cut it into 4 parts, the first thing we're going to do is 54 divided by 2. And we're lucky it's even. So we know that 54 divided by 2 is 27. So that means we're going to go to this list here, which is in order from smallest to greatest. We have to make sure things are in order from smallest to largest. Okay, so we count down to number 27. And it turns out that's tangerines. Okay, so here's my half. So now I have 27 up here and I have 27 down here. But now I need to cut those in half. But let's just be clear, the median falls in between those two. So to find the value of the median, we have to find the average of those two. Basically what number lies halfway between 53 and 56, and that's 54.5. But I don't want to focus on the values right now. I just want to focus on how to cut this into 4 equal pieces. So now let's just look at this top half. I've got 27 items in this top half, and I need to cut this into 2 teams of equal size, but I have an odd number, okay? And I like to say teams because it's more intuitive of what needs to happen if I'm going to have 2 teams of equal size with 27 people to pick from. I need to divide it by 2 again. That's 13.5. Can I have 2 teams with 13 and a half people in it?
One away from one of the groups?
Exactly. If we have 26 people and we need to get 2 teams of equal size, someone's got to sit out. And so that's what's going to happen here. We have 13 and a half, which means we count down. We find that 13th one, and it turns out who has to sit out is cranberries. They don't get to play. And then we have 2 teams where here I have 13 people and here I have 13. So that's how we create 4 teams of equal size. Sometimes we got to throw somebody out of the game. Somebody's got to sit on the bench.
You always throw out one from the middle.
If I have to throw somebody out, it's the person in the middle. Yes. This first half, this is 25% of my data. The second half is 25% of my data. And then we do the same thing down here. We have another group of 27. We've got to figure out how to split that into 2 equal size groups. So again, somebody's got to sit out, and here it's jujubes. Jujubes is the median for the second half of data. What we have is another group of 13. This is 25%. And another group of 13, and that's 25%. Okay, so if you wind up with an odd number, you find the median, and the median is the one that sits it out. This median, the jujubes, this is what we call Q3. Here is the median in between tangerine and currants. And then cranberries is what we call Q1. Those are 3 values in that 5-number summary we use to make the box plot. The other 2 items, the min, and then the largest is 299. So that's our max. And this is why we need things in order, because you can only find the median if things are in order from smallest to largest. And then we put them here.
Does Q1 represent cranberries?
Yes, Q1 is cranberries. Q1 is the median for the first half of data.
Okay.
And yes, that is cranberries. Good question.
So what you're saying for the medium, it's okay to have it like as a percent, like a 54.5, like an extra like decimal.
Yep, absolutely. Just for sake of argument, let's say our list was just this: 49, 50, 50, 50, 50. I'm just looking at these, then my median is here. Okay, so there's my median. But if I just added one more, and let's say now we're looking at this list, my median's going to be here. Okay, and what number is halfway in between 50 and 50? It's still 50. When you're doing these quartiles and when you're dividing these into equal sets, there's not a one size fits all of it's going to be a solid number. It's not. It's going to be in between 2 values. It's going to be a value. It all just depends on how your numbers shake out. It depends on whether or not The number of data points you have is divisible by 4. Don't think about it that way though. Just, I need to sort the data from smallest to largest. I need to find the middle value, split it in half, equal size. Then for each of those, again, find the middle value, split it in half, and get 2 equal sizes. So the whole point of all of this is we need to make 4 teams with the same number of people on every team. Okay, cut it in half, and then cut it in half, and then cut it in half. Okay, let's go down to the next part then. I'll show you what I have. So you see, I kind of drew the box plot here just to help you visualize where each of these things come in to play. What it turns out, we're going to get these numbers from our calculator most of the time. It's easier. This is what our calculator would spit out, that fruit list. I would never have you put a list that long into your calculator. This is what it looks like. And you see this little arrow right here that we got means that there's more lists above. So this is the one variable stats that we use to get the mean and the standard deviation. If we scroll down on this, that's where we get our 5-number summary. Here's what the box plot looks like for our data. I copied the 5-number summary over here. We have the min, Q1, Q3, the median, and the mat. Remember, there's in equal numbers represented in each part of this. So this part here is 25%, and there's 13 fruits. 25%, 13 fruits. This part here, 25%, 13 fruits. This part here, 25%. And 13 fruits. What this allows us to see very clearly, much more clearly than we would get on a histogram, is I look at this and I go, what is going on here? Is this an outlier? It sure the heck looks like it, right? Sorry, I live on a very loud street with lots of loud motorcycles, where if we had a histogram, that wouldn't be as obvious. And we look back at our list of data and you see, I mean, look at this, they're all hundreds, and then it jumps to 240, and then 282, and then 299. This is another hint that, yeah, I mean, that's quite the jump here. Some of these might be outliers. So with the histograms, we use the standard deviation to tell if there were outliers. But with the box plots, we used to call it box and whiskers. It's not so common anymore because these are the whiskers. Instead of using the standard deviation to figure out where there are outliers, we use this box. Again, going back to the histograms, we use the mean, and then we went 1 standard deviation on either way, and that's where the bulk of the data was. It's here, 1 standard deviation on either side. Most of the data is in this area here. With the box plots, we get the same information, except now what we know is that most of the data is here. In fact, we can be more specific. What percentage of the data is here? It's 50%. So we know that most fruit is between 46 and 79 calories. But now how we determine if there's unusual or outliers data, we use the width of this, which is called the IQR, interquartile range, is the width of this box. So this width of this box is going to behave like our standard deviation. And we're going to use that to determine what the outlier fruits are. And there's a formula down below on the next page, but I'm going to explain to you how we got that formula. So we take the width of this box. I've just copied this box and changed the color, and we go 1.5 boxes above. Then we say anything past here is an outlier. This is what we call our fence. Anything outside our fence is an outlier. Okay, and then we do the same thing in the other direction. Boxes away, and then we say anything beyond here is an outlier, just like we did with the histograms. Anything out here is an outlier. Of course, that doesn't make any sense because our fruit can't have negative calories. So that's how we get the 1.5 times the width of this box here. That's what we're doing. Okay, and if you look down here, when you remade it with your fences, we end our box plot at the next point, which is 127. And then these other 4 fruit become outliers.
For number 14, you put Q1 equals 44. Wouldn't it be 46?
You're absolutely correct. That is a typo. That should be 46. So let's move on to example 3. Okay, let's practice using our calculators. I had asked you to put this data into your calculator before class, and I asked you to do that because putting this data into your calculator during class is time consuming. Pull out your calculators, put this in the calculator. I'm going to quit this screen, clear it. So here I'm on the regular screen. And so remember, to get the list, you're going to go to Stat, Enter, because we want Edit. And then here I have List 1, non-players, List 2 is the beginners, and List 3 is the tournament players. If you ever don't see L1 here, let me know. If you can't get L1, we have to do something special. So I'm going to show you how to get these box plots. As you see up here above the y equals, the top left button, it says Stat Plot. That's what we're going to be using. And just so you know, I'm not having you do this on a test. The graphing aspect is too complicated for a test. It's important for you to see everything, how to use the calculator and to do it, but not on the test. So we're going to press second y equals, and this for you will probably say off. We're going to press enter, and yours probably looks like this, where it's off. Put your cursor over on and press enter. Okay, then we want to arrow down to type. And see this first type, this is scatter plots. We're actually going to be doing that tomorrow. And then line graphs, then histogram, then box plots with outliers and box plots with outliers. And I'm not sure what this next one is. Press enter. For our purposes, I happen to know there's no outliers for these ones. Remember on that first example, we graphed it first without outliers and then we graphed it with outliers. For different purposes, you may or may not want the first one. You can use either one, it doesn't matter. Scroll down. The X list, this is where your data is. So you want to make sure that says L1. It should default to L1, but for the next two, you definitely want to double check that it's switching to L2 and L3 respectively. To make sure L1 is there, press second 1, and you see again in blue it says L1 right here. For L2, you would press second 2. That's where it says L2. L3 would be second 3. Okay, and then scroll down. Frequency, leave that alone. That should be 1. Don't mess with that. That messes everything up. I don't know why. I don't know what it does. Okay, and then scroll down. And if you have one of these fancy calculators, you can change the color. What we want to do now is we want to make sure the calculator only puts the graph where it needs to be and doesn't give us a whole bunch of extra stuff. So click zoom, and you see number 9 is zoom stat. That's what we want. And you don't have to scroll down, you can just press the number 9. And then there's your lovely box plot. After you put in the data for L2 and L3, then we're going to go back to second y equals and then repeat those steps for plot 2 and plot 3. Okay, but what's nice is if I go into plot 2, you see how it says plot 1 and plot 3? Once you put in everything you want for plot 2, turn it on, scroll over, highlight the box plot, go down, make sure that says L2, yours, choose the color. Then you can just arrow up and scroll over to plot 3, highlight plot 3, press enter, and there you can turn on plot 3. To graph it, zoom 9 for zoom stat. Zoom stat will adjust the screen so that all of those fit on the same screen. I'd like you to work on this example 3. Beyond this problem, all the other box plots we're going to do are going to be horizontal. I already have the box plots here. Let's just go over how to find the 5-number summary. That's one thing I'm going to ask you to do in the test. And what's great about this is we get that all from our calculator, but it's really important to know how to do it by hand because I can find it by hand faster than you can even enter the list in your calculator. So we need the min, Q1, median, Q3, and the max. And remember, Q1 is the median of the bottom half of the data, and Q3 is the median of the top half of the data. So first we want to find the middle. I can't show you here. It's hard to do it, but what I do is I just use my fingers and go on each end and then go in by one, 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 and then my fingers wind up in the middle. The median is right here. Okay, so we need to do a little bit of math and figure out what number is in between each of these. And it turns out it's 32.6, 48.4, and 64.6. So remember, for each of these, we're just finding the average of these two. Find what values in the middle here, right here, and right here. Here's Q1, and here's Q3. And then in each case, we have the min in the first line and the max in the bottom line. And then we use those to make these 3 lovely box plots. But you can see here clearly, tournament players did better. On average and overall, the bulk of the players even did better. Let's look at how our calculators do it. Again, go to stat plot, and I'm going to go down to 3 because I see that's the only one that's off. going to turn that on. Make sure box plot is highlighted. It is. Make sure L3 is there. Remember that would be second 3 to get an L3 there. Then to graph them, I'm going to go to Zoom 9, which is Zoom Stat. When we first did it with L1, the blue box took up the entire width. Now that I have all 3, it's adjusted that view so that I can see all 3 very nicely. That matches the graphs that I drew by hand. Let's move on to percentiles. Percentiles, hopefully you're all somewhat familiar with percentiles. If you have children, the doctor always gives you your child's weight, height, etc., their stats as a percentile. If you took the SAT or the ACT, you got a percentile. Some high schools even now give percentile for where you are in your class relative to other students, right? The important thing with percentiles to understand is that the percentile is referring to how many people you are better than. So 85th percentile means you're better than 85% of those people. So be careful though, because we do look at percentiles in 2 different ways. We use the term percentile to refer to how many people are behind you, but then we also talk about the top percentage. So if I was going to talk about the top 10%, is that the 10th percentile?
No.
Good. So what is it? What percentile?
90.
Yes, good job. Because the top 10%, that's talking about how many people are above, but you want to know how many people are below. So that would, the top 10% is also known as the 90th percentile. So let's go down to example 5 then, and we're going to talk about 10 standardized test scores. Okay, you can think of it, this is like an ACT or SAT style test. How you read this, it's a little bit confusing because this really should be one long column, but it's so long that we've kind of doubled it over. We've cut it in half and then put the bottom half next to it. So on this table, we have the score, percentage below, which we know now, percentage below has another term for it, yes? Percentile. So these are all percentiles. Here, the score of 29, 27th percentile data continues over here in this column. So score of 28 is the 25th percentile. And you're told that there's over 600,000 candidates whose scores are represented here. You're told the mean and the standard deviation. I'd like you to do as many of these as you can. The 99th percentile, remember that column that says percentage below is referring to percentiles. So you want to look and see where does it say 99, and that's that first row, 51 to 60. Okay, so if examinees scored in the 99th percentile, then blank percent of examinees scored lower. Well, that's 99. Let's skip to 42, because again, I just wanted to practice percentiles. What scores are in the top 10%? Well, remember, like we had said earlier, that this is the 90th percentile. So that's here. That's a score of 49. Then the bottom 10% is actually the 10th percentile. Again, remember here, our columns say what percentage is below. That's here. That's a score of 21. I'm sorry, I just realized I made a small mistake on 42 and 43. Let me back up. It says what scores, plural, are in the bottom 10%. So the bottom 10% is 21 and below. So all of these 0 to 21. And then backing up to 42, what scores are in the top 10%? Again, that score of 49 is the cutoff for the top 10%. So these are the scores of 49 and above. So 49 to 60. So what percent of examinees scored below 30 scored 29? So that's 27%. Notice there's no 30%. 30% is missing. So it jumps from 31% to 27%. Okay, so how many examinees is that? Well, we'd have to figure out what is 27% of 622,975. All right, so that would be 0.27 times 622,975. 168,203. Just to point out, 46 is using that standard deviation like we did with the histograms in lesson 6. Key remember is on Canvas. I will upload a corrected version because there are a couple mistakes that we found. Next class, what we're going to work on correlations. So comparing 2 different variables and seeing how they're related to each other, if at all. In lesson 9, I'm looking at modeling data, using what we know already to predict what's going to happen in the future. Okay, and we call that a model. And that'll be regression line. Okay, so if you need help with anything, if you have any questions, remember I'm going to be sticking around for the next 20 minutes. Other than that, have a great afternoon. Good to see all you all.